Module 4 is going to cover basic math, stats, and quantitative reasoning for journalists, and I'm going to give you an overview of the main points from the material and break down the assignments that we're going to do in this module. One of the two main emphasis of the module is calculating central tendency, and that's mean, median, and mode. You've probably heard of these terms in math courses if you took a stats class. We're going to revisit them here. Mean is just the average, summing everything up and divided it by the number. Median is the tool we're going to use to better control for outliers, and we'll give you a couple examples of those in the lecture, and then you'll also see it in the material we read. And then mode is simply the most common pattern of reoccurrence, so it's the value in there that reoccurs the most. It could be more than one, so there could be a tie for mode. With mean, you sum all the values, you divide by the numbers. So here in this easy example, 300, 400, 500, the mean is 400. Just sum to 1200 and divide by 3. Pretty easy. We're not going to do a lot of hand calculations in the course, but this will be the module where we do some of it so you can understand it when we apply it to spreadsheet applications. And this provides, with mean, a point of comparison between the groups. It's useful for most instances. We'll talk about the exceptions when you might want to use the other two. Here's one of the great examples of when mean is not the best when comparing salaries. The famous example of entry-level salaries for UNC Chapel Hill graduates from 1984 data. And as you can see, when they compared across careers, you would expect things like business or engineering to have high average salaries based on labor statistics from the government. But in this case, geography was significantly higher, and they couldn't figure out at first glance why that may be the case. And it turns out in this case we had an outlier who really skewed the values. This was when Michael Jordan was drafted by the Chicago Bulls, given a really large contract. He was a geography major and graduate from UNC, and so you can see how his value there really pulled the mean over and distorted the true, what we would think of as average or median salary of geography majors in that year. So it turns out that's a great example to keep in mind if you're interested in basketball or just familiar with it, of the reason in which you would try to keep in mind situations where the median is preferable. So it's more accurate with those extreme kind of values. What you simply do, if you hand do it, is you sort them in descending order. We'll also see how to do this in spreadsheets. And if it's odd, you take the middle value, and if it is even, you take the average of the two middle values. So look at this example with these values. We just rearrange them. We see 400s in the middle, and therefore that is the median. When we calculate the two middle values, we reshape them. We look at the 400 and 500 being in the middle, and we do the average. So the median in that case for that set of four values would be 450. Mode is simply the most often used in statistics. It's the most recurring value that we see. In journalism, this is not one we're going to use as frequently as mean or median, but it's a good one to know because it's right in there with central tendency. And so in this case, you look for the most recurring value, and you can see in the data set listed there, it's clearly 400. The second of the big points of emphasis when we start into math for journalists, and if you get these kind of things down, you're ahead of 80 or 90% of journalists or people working with basic numbers and spreadsheets, is percent and things like percent change. So it merely means per 100, and this helps standardize the units for comparison. So the logic behind this makes a lot of sense, even if you're somebody who self-identifies as more challenged with math or less familiar with it. If you keep in mind the basis and the logic of what we're trying to do with these simple things we're going to practice, I think you'll find them really effective. So this helps describe the data from raw numbers in a way that really relates to ways readers can understand. And it's more common and easier to get than ratios. So anywhere we have a ratio, a lot of times if you can put that in percent and relate it to somebody's lived experience, that's a whole lot more effective. We're going to keep in mind things like times as many and times more, using the former when it comes down to that kind of language. Mostly what I'll be asking you to do is look at ways to calculate percentages, and percent change over time is going to be a frequent one that we really focus on. So here's calculating percentage. You just divide it. Divide the number by the larger total and multiply by 100. So you can see here what's our percentage of journalism majors out of the students. It's 3.95%. You can do it with a calculator. We'll also, in the coming module, see how to use spreadsheet formulas to calculate the same thing. One of our big ones is going to be percent change, and this helps explain the difference in change in time or something like price or how often. And so it's really new minus old divided by old, or initial minus change. We're going to continue to repeat that, and there's some resources to read it, to look at videos, so you can get this down if you have trouble with it. But it'll help you explain things like an increase of $20 to $35 is really a 75% increase, or if you decrease from $35 to $30, that's a 14.3% decrease. We're simply putting things in the proper order of doing a simple subtraction step, and then dividing by the total of what we want to see, and then calculating it that way. And you can also do it the reverse. So for example, what's 20% off a $40 shirt? We figure out what 20% is, and then we subtract it, and we see that it's 32. And that tells us, once we calculate it, the 20% off, we can do it in reverse and double check that math. We'll also do percentage of the total, and that's how one value in a collection contributes to the entire collection. So you add all the values, you divide by the total, then multiply by 100. So for example, if you're looking at a budget, 2,000 here, 2,000 there, 1,000 there, 5,000 there, what's the percent of the total budget for one of those pieces? We add it all up, we divide, we see for investigative reporting, it's 20%. And finally, we're going to look at things like per capita and inflation, and that's just simply dividing by the individual. So it's a great way to establish rates per person and do comparisons like across countries or cities. And so you're going to see some of that in the homework for the module, making comparisons in which we standardize per capita and see what spending is per person based on large and small places. Finally, we're going to adjust for inflation. You'll see this a lot of times in these examples with movies. It's more per ticket. There's more theaters. How can we compare really the cultural impact sometimes of films? So that's a really good example of making standard comparisons across time when money's involved. And for that, we'll use something like the CPI inflation calculator from the Bureau of Labor and Statistics. That's this consumer price index. And you can see when you do that, if you adjust, you'll see things like in the adjusted for inflation, Hunger Games getting in there, Avatar, more recent films like the Avengers. Those are ones in which we have not sorted or adjusted for inflation. On the left there, it's unadjusted growth. So you see that's just the raw number they brought in years like 2013. When we standardize it on the right, you can see older films like Gone with the Wind or Star Wars, Sound of Music jump to the top, because what we're essentially doing in adjusting for inflation is saying those tickets sold back then at the value that $1 was are now worth a lot more if they would be in today's dollars. So it gives you a more well-rounded logical basis of historical comparison. You can also do this in news stories, such as one here from the Hartford Courant, where we look at a minimum wage. And if you're just talking about things like wages and not adjusting for inflation, you could miss the point. And the visualization here really helps show you that there's been many times that the minimum wage in 2014 dollars was higher or at the same point. It's just that inflation surpassed that wage, and so that's an important way you can put context in your reporting on things like increases in wages and adjusting for inflation. So we'll practice all that in this module, and we'll do it in a few different ways. There's a homework in which you will do some hand practice with central tendency percentages, inflation, and per capita, and this will be the only module in which we do a lot of this hand calculated stuff, but it's really important to understand the basics behind it in a really simple way before we get into learning it on the spreadsheets and in other different formats. You'll do a quiz based on the reading, a couple chapters from Meyer, some of the short chapters from the Cohen reading, and a couple links about common math stats for journalists and ways you can see these formulas in different ways, so you can hopefully connect with them in a way that really works for you. And if you don't, please email me. I'm glad to help you figure out a way or additional resources to do that. And then finally, in the discussion, we're going to find and evaluate. You're going to find a news story that uses central tendency, like a mean, median, or mode, or a percent change in everyday journalism, and we're going to say, hey, does that effectively do that? Just kind of get you used to paying attention, looking out in your own news consumption for when these kinds of skills that we're introducing are used there, so you can better understand how journalists use them every day. So that is the module, and I hope you take a lot away from it. If you have any questions, please let me know, and thanks a whole bunch. Bye-bye.